Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3501, Compiler Design, Unit 2, Topic, Role of Parser, Grammar, Context-Free Grammar. Role of parser. The parser or syntactic analyzer obtains a string of tokens from the lexical analyzer and verifies that the string can be generated by the grammar for the source language. It reports any syntax errors in the program. It also recovers from commonly occurring errors so that it can continue processing its input. In this diagram, it shows the role of parser. First step, if we are going to give the source program, then it is converted into the lexical analyzer, and what are the errors occurs, it is rectified from the symbol table. Role of parser. Parser builds the parse tree. Parser verifies the structure generated by the tokens based on the grammar that is used to perform context-free syntax analysis. Parser helps to construct intermediate code. Parser produces appropriate error messages. Parser performs error recovery. Issues. Parser cannot detect errors such as variable redeclaration, variable initialization before use, data type mismatch for an operation. Grammars. Constructs that begin with keywords like while or int are relatively easy to parse because the keyword guides the choice of the grammar production that must be applied to match the input. Consider the grammar for expressions which present more of challenge because of the associativity and precedence of operators. E tends to E plus T, T tends to T asterisk F tends to EID. In the following expression, grammar E represents expression consisting of terms separated by plus sign. T represents terms consisting of factors separated by multiplication sign, and F represents factors that can be either parenthesis expressions or identifiers. Error handling programs can obtain errors at many different levels. For example, lexical such as misspelling, identifier, keywords, or operators. Syntactic such as misplaced semicolons or extra or mixing braces, a case statement without an closing switch statement. Semantics such as type mismatches between operators and operands. Logical such as an assignment operator equal instead of the comparison operator equal infinitely recursive call. Functions of error handler. It should report the presence of errors clearly and accurately. It should recover from each error quickly enough to be able to detect subsequent errors. It should not significantly slow down the processing of correct programs. Error recovery strategies. Once an error is detected, the parser should recover from the error. The following recovery strategies are: panic mode. On discovering an error, the parser discards input symbols one at a time until one of a designated set of synchronizing tokens is found. The synchronizing tokens are usually delimiters such as semicolon or whose role in the source program is clear and unambiguous. Phrase level. When an error is identified, a parser may perform local corrections on the remaining input, that is, it may replace a prefix of the remaining input by some string that allows the parser to continue. A typical local correction is to replace a comma by a semicolon, delete an extraneous semicolon, or insert a missing semicolon. Phrase level replacement has been used in several error repairing compilers as it can correct any input string. Its major drawback is the difficulty it has in coping with the situations in which the actual error has occurred before the point of detection. Error productions. The common errors that might be encountered or anticipated and augment the grammar for the language and hand with the productions that generate the erroneous constructs. Global correction. A compiler need to make few changes as possible in processing an incorrect input string. There are algorithms for choosing a minimal sequence of changes to obtain a globally least cost correction. Given an incorrect input string X and grammar G, these algorithms will find a parse for a related string Y such that the number of insertions, deletions, and changes of token required to transform X into Y is as small as possible. These methods are in general too costly to implement in terms of time and space, with the situations in which the actual error has occurred before the point of detection. Context free grammar. Grammars are used to systematically describe the syntax of programming language constructs like expressions and statements. Using a syntax variable statement to denote statements and variable expr to denote expressions is the example for the given context free grammar. The formal definition of a context-free grammar, it is defined by the four tuple g equal to v, comma t, comma p, comma s, where v is a finite set of non-terminals or variable, t is a finite set of terminals, s is the set start table. The productions of a grammar specify the manner in which the terminals and non-terminals can be combined to form strings. Notational conventions. First, we are going to further some notations for the terminals. Lowercase letters early in the alphabet such as A, B, C. Operator symbols plus asterisk dot dot. Punctuation symbols such as parenthesis, comma, and so on. The digits 0, 1, dot, dot, 9. Bold case strings such as ID or if, each of which represents a single terminal symbol. Now, next, we are going to see the some of the notations for the non-terminals. Uppercase letters early in the alphabet such as capital A, B, C. The letters S, which when it appears is usually the star symbol. Lowercase italic means such as EXP or statement. Derivations. Derivation is a process that generates a valid string with the help of grammar by replacing the non-terminals on the left with a string on the right side of the production. Types of derivations. There are two types of derivations. First, we are going to see the leftmost derivation. The leftmost derivation non-terminal in each sentinel is always chosen first for replacement. The next one is rightmost derivation. In this, the non-terminal in each sentinel is always chosen first for replacement. Rightmost derivations are sometimes called canonical derivations. These are the example for the leftmost derivation and rightmost derivation. First, we are going to do the leftmost derivation for the given production of grammar. At last, you have to do the rightmost derivation also. Parse tree and derivation. A parse tree is a graphical representation of a derivation that filters out the other in which productions are applied to replace non-terminals. Each interior node of a parse tree represents the application of a production. The interior node is replaced with non-terminal A in the head of the production. The children of the node are labeled from left to right by the symbols in the body of the production by which this A was replaced during the derivation. Ambiguity. A grammar produces more than one parse tree for some sentences said to be ambiguous. A grammar G is said to be ambiguous if it has more than one parse tree either in leftmost derivation or in rightmost derivation for at least one string. Thank you.